Welcome to my exciting series on developing a real Google Docs clone. That means we will be going much further than creating a Notion clone or a simple text editor. To begin, check out this demo of the end product. In this video, we will create the beginnings of a fully formatted multi-page document editor. This code is available as an NPM module for use in your projects, as well as on GitHub for reference. We will simply walk through the code and explain it in detail. Let's dive in. This code snippet initializes the JavaScript module for our multi-page rich text editor with the following key components. 1. Imports. Component rope. This is a local import from a module responsible for managing the document's text content in an efficient way. This rope was adapted from another open source module, and the author is credited in this repo. Interval tree. Used for efficiently storing and querying intervals, which could relate to formatting ranges. FontKit, a library for working with fonts, primarily for text sizing and positioning. UUID v4, a function from the UUID library used for generating unique identifiers, which is helpful for identifying document elements. Buffer, imported from the Buffer module, it is used for handling binary data. It's assigned to window.buffer to make it available globally, ensuring compatibility with browser environments. 3. Interface declaration. The mapped format interface defines a structure for mapping a format, likely a text style, to a specific interval within the text. Interval, an object containing high and low properties that define the range of the interval. Format, a property of type style, which refers to text styling, bold, italic, etc. Here we define several TypeScript interfaces used in our multi-page rich text editor. Formatted text represents a piece of text with associated formatting. Text, a string containing the actual text content. Format, an optional property of type style or null, representing the text's formatting details, e.g. font style, size. Font data describes the characteristics of a font. URL, a string specifying the public location of the font file. A string for the font's CSS name. Font, an optional property of type fontkit.font, which may hold a font object for use when determining character layout. 3. Render item represents a graphical element for rendering a character on a page. Real char, the actual character in the typed by the user. Char, the displayed character, which might differ due to markdown signifiers such as dashes or pounds. X and Y, numerical values for the character's position on the page. Width and height, dimensions of the rendered character. Cap height, a measurement relevant to the font for determining line height. Format, the style associated with the character, defining its visual appearance. Page, the page number on which the character is rendered. These interfaces structure the data used for text formatting, font management, and rendering in the editor, promoting type safety and clarity. Here we continue with our TypeScript types and interfaces. 1. Style, a TypeScript type representing the visual properties of text. Most of these properties are rather self-explanatory. 2. Document size, an interface representing the dimensions of a document in pixels. 3. Margin size, a type for defining the margins around content. X, a number representing the horizontal margin, left and right. Y, a number representing the vertical margin, top and bottom. These definitions help manage text appearance and document layout in the editor. This code snippet defines an enumeration and 2 interfaces. 1. Visual kinds, an enumeration, enum, that categorizes different types of visual elements that can be rendered in the editor, starting with circle, rectangle, and image. 2. Visual, an interface representing a visual element on the page. Most of these properties are self-explanatory, except fill, a string that likely specifies the color or pattern used to fill the visual. URL, a string representing the source URL for an image, if applicable. 3. Kerning cache, an interface serving as a cache for kerning values, which are adjustments to space between characters. It uses a string as a key, possibly a character pair, and returns a number representing the kerning adjustment. These definitions enable structured representation and management of visual elements and kerning in the editor's layout and rendering logic. This portion defines default configurations for a visual element and text styling. 1. Default visual, an object of type visual that represents a default visual element. We set some defaults that will either be overridden or acceptable as starting values. 2. Letter spacing, a variable defined with a value of 1, which creates a default spacing between letters and increases legibility. 3. Default style, an object of type style representing the default text styling. You may want to set the default font to one that you have loaded. This code snippet performs the following functions. 1. Kerning cache initialization, const kerning cache equals, initializes an empty object to cache kerning values based on character pairs. 2. Blob to buffer conversion. Blob to buffer is an asynchronous function that converts a blob object into a buffer. It uses blob.arrayBuffer to read the blob as an array buffer, which is then converted into a buffer using the window.buffer.from method. This is necessary for compatibility with FontKit 3. Loading fonts. The load fonts function is an asynchronous function that takes two parameters, a callback function, setFonts, to handle the loaded font, and an array of font URLs. Inside the function, a try block initializes an empty font data array. It iterates over each font item in font URLs using for_await, allowing asynchronous handling of each URL. For each font URL, it fetches the font data, converts it from a blob to a buffer, and then uses fontkit.createBuffer to create a font object. The resulting font data, URL, name, and font object, is stored in the font data array. This snippet is designed to efficiently load and prepare font data for use in our rich text editor. This snippet continues from the previous font loading functionality. Error handling. The catch block handles errors that occurred during font loading. It logs the error details along with the font URLs that failed to load. 2. Global window extensions. The declare global block extends the global window interface by adding two properties. Canvas RTE insert character index, a number to track the current insertion index of a character in the editor. Canvas insert character index L, another number for tracking insertion position except with new lines counted. You will learn that new lines are tricky to work with JavaScript strings. 3. Initialization. Both extended properties are initialized to 0, preparing them for use within the application. 4. Layout tree class. A class named layout tree is defined. It has a public property root that is initialized as a new layout node with parameters 0, infinity, indicating the root of the layout hierarchy. Another public property, maxSafeInt, is set to 3000, which is a constant to represent safe limits for layout calculations. Now we dive into our custom tree structure for handling layout, which, like most trees, will make the storing, updating, and retrieval of data much faster. 1. Methods of layout tree. Update start number, end number, layout info render item calls the update method on the root node, passing the specified range start and end, and layout information layout info. Query start number, end number calls the query method on the root node to retrieve information for the specified range. Query info's index number retrieves layout information for a specific index from the first query result for the range from 0 to the maximum, this.root.max. 2. Layout node class. The layout node class represents a single node in the layout tree with properties for its start and end positions, start, end, left and right child nodes, left, right, layout data, layout info, and a maximum value, max. The constructor initializes these properties, optionally setting the layout info to null if not provided. Overall, this snippet is integral to maintaining and querying the render layout structure in the editor, allowing for updates and efficient layout information retrieval. Here we continue the layout node class definition with property initialization and an update method. 1. Property initialization. This.left and this right are initialized to null, indicating that the node has no children initially. This.layoutinfo is set to the provided layout info or null if not provided. This max is assigned the value of end, which helps determine if a given range intersects with this node's range efficiently. 2. Update method. The update method modifies the layout info for this node based on the specified range, start and end. It first checks if the update range is entirely outside this node's bounds, end this.start or start this.end, in which case it returns immediately without changes. If the update range completely encompasses this node, start this.start and end this.end, the method also exits without any changes. If neither condition applies, the method recursively calls update on the left child node if it exists to propagate the update. With these algorithms, we avoid overcalculating the entire tree. This code snippet continues the update method in the layout node class and begins the query method. 1. Updating right child. If the node has a right child, this.right, it calls update on that right child with the specified start, end, and layout info. 2. Splitting leaf nodes. If the node is a leaf, i.e. it has no left or right children, and the update affects its range, the split method is invoked to divide this node into subnodes. 3. Updating max value. The node's max value is updated to reflect the maximum of its own end value, or the max values from its left and right children if they exist. This helps maintain accurate node boundaries for efficient querying. 4. Query method. The query method checks if the specified query range, start, end, is completely outside this node's range. If it is end equals this.start or start is this.max, it returns an empty array indicating no relevant nodes are found. We have 2 more methods within the layout node class, query and split. 1. Query method. If the node is a leaf, no children, it returns an array containing a new layout node initialized with the current node's range and layout information. If the node has children, it initializes an empty result array and recursively queries both left and right children for layout nodes overlapping the specified range, start, end. The results from both children are concatenated to the result array. Finally, it returns the aggregated result array of layout nodes. 2. Split method. The split method calculates the midpoint of the node's range and creates 2 new child nodes, left and right, each representing half of the original node's range. If the current node has layout info, this information is assigned to both child nodes, ensuring they inherit the layout data. Overall, these methods facilitate querying the layout tree and ensure efficient subdivision of the tree structure when necessary. This code snippet begins the formatted page class, which represents a single page with specific characteristics. 1. Properties. Content. An instance of component rope, storing the text content of the page. Formatting. An instance of interval tree, managing formatting information, e.g. font styles, sizes, over intervals of the content. Layout. An instance of layout tree, handling the layout structure for rendering the content visually. Size. An object of type document size, representing the dimensions of the page. Page number. A numeric identifier for the page. 2. Constructor. The constructor simply initializes each property in an empty state, along with provided font data. This portion contains 2 methods within our formatted page class for handling content retrieval and insertion. 1. getChar@index. This method retrieves a single character from the page's content at the specified local index NL, which is the index with new lines included. 2. insert. This method begins by marking the performance metric for the insertion process, so we can profile in the dev tools. It splits the provided text into an array of lines based on new line characters, so we can properly handle new lines. Several variables are initialized, including current index, current NL index, and counters for tracking progress. The method iterates over each line. For each line, it ensures the indices do not exceed content length, and if the line contains any characters, excluding new lines, it calls an insert function on content to insert the line at the specified current NL index. This code snippet continues the insert method, handling the insertion of formatted text into our rich text editor as follows. 1. Formatting insertion. After inserting a line of text into content, it updates the formatting structure by inserting a new interval that represents the formatted range of the inserted line, from current index to current index plus line.length, with the specified format. Since new lines are not tracked in our formatting structure, we don't use the new line index 2. Length calculation. The length of the inserted line is added to total inserted length, tracking the cumulative length of all text inserted. 3. Line break handling. After processing each line, if it's not the last line in the array, a line break is inserted using insert line break, which updates current index and current NL index accordingly. The line break insertion increments total inserted length as well. 4. The line's finished counter is incremented to keep track of how many lines have been processed. Next, we handle two main actions at the end of a text insertion process and begins a method for inserting JSON-rendered items. 1. Completion of insertion. After inserting text into the document, a callback function is invoked, passing the current index and total inserted length to notify any listeners about the insertion results. This allows us to shift formatting intervals after an insertion is made, so they maintain their correct positioning. Performance monitoring markers are established, marking the end of the insertion process and measuring the time taken for the insertion. 2. Starting insert JSON method. This method prepares to process an array of render item objects, initializing variables for formatting management, current format, format start, format end, format diff, and content tracking, content index. This method is necessary to restore or initialize the editor from a JSON object which is output by the editor when content is updated. A loop iterates through each render item, checking for new line characters in previous elements to determine if a new line has started. Here is more of the insert JSON method, which handles the insertion of individual characters from a render item array into the content. 1. Character insertion. It inserts renderItem.realChar at the position content index 1 in this .content. The real chars are represented in the content structure. 2 special cases for new lines. Here we handle some markdown signifiers, which we process in a special way due to how the JSON is output. Handles cases when the current character, realchar, is a hyphen or a hash symbol hashtag and is at the start of a new line, indicated by isNewLine, and if the next character, nextRenderItem.realchar, is a space. Now we check for changes in text formatting during a JSON insertion process. 1. Initial format assignment. If current format is not yet defined, it is set to the format from the current render item. 2. Format change detection. It compares properties of current format, e.g. color, font family, font size, etc., with those of the current render item.format. If any property differs, it indicates a formatting change. Insert formatting interval. When a change is detected, it inserts a new interval into this .formatting, using format start and format end 1 to define the range and applying the current format. 4. Update tracking variables. It updates format start by adding format diff, assigns the new render item.format to current format, and resets format diff to 0. This assures that formatting intervals are as long as they can be, but no longer, which enhances overall performance. This consists of 2 main parts. 1. Formatting increment. Wrapping up the insert JSON method, this increases format end and format diff to extend the range for the current formatting and sets isNewLine to false. 2. Shifting formatting intervals. The shift intervals after method retrieves all formatting intervals within the content. It clears the existing intervals and then iterates over each interval. For intervals that start at or after the specified index, it shifts their start and end points by the shift amount and reinserts them into the formatting structure, effectively adjusting their positions in response to content changes. This is how we keep our data structures, which are so important for performance, completely in sync. Now we handle 2 primary functionalities. 1. Interval handling. Here we wrap up the shift intervals after method by checking the relationship between existing formatting intervals and the specified index. If an interval's end overlaps with the index, it extends that interval's end by shift amount. If an interval is entirely before the index, it simply reinserts it as is without modification. 2. Line break insertion. The insert line break method inserts a line break into the content at the NL index. It ensures that the index and NL index do not exceed the content length. A new formatting interval is created for the line break with default styles and an isLineBreak property set to true, which is also inserted into the formatting structure. This code snippet defines 2 functions, delete and adjust formatting. 1. Delete method. This method removes a range of content specified by start and end, and optionally handles new line positions, NL start, NL end. It calculates the length of deletion, removes the content and associated formatting within the specified range, and then calls adjust formatting to update the formatting indexes based on the deleted length. After completing the deletion and adjustments, it invokes an optional callback. Adjust formatting method. This method iterates through all existing formatting intervals. If an interval starts at or after the specified index, it shifts the interval's start and end positions by the given length. If an interval ends after the index, it also needs to be adjusted, enabling a seamless update of formatting after content deletion. Here we extend the adjust formatting method to finish updating formatting intervals after possible adjustments. 1. Inserting adjusted formatting. It inserts the adjusted formatting back into this formatting, shifting the end of each interval by length. 2. And we continue with a similarly named method, the alter formatting method. This method modifies the formatting of text within a specified range, start to end. It ensures the indices are within valid bounds of the content length. It retrieves existing formatting in the specified range, removes those intervals, and prepares to apply new formatting. It calculates the new bounds, new start, new end, for each existing interval based on the provided formatting changes. Here we continue the alter formatting method with the following tasks. 1. Conditionally update formatting. If new start is less than new end, it merges existing format with format changes to create updated format. It then removes the old formatting in the interval, new start, new end, and inserts the new formatting. 2. Fill gaps with new formatting. If there are no existing formats or if there are gaps before start or after end, it creates a new style by merging default style with format changes and inserts this new formatting for the entire interval between format start and format end. Overall, this snippet ensures that the specified text range is updated with new formatting and any gaps in formatting are filled appropriately. This code snippet manages the layout updates and retrieval of formatted text. 1. Update layout. The invocation of this .update layout ensures that the entire content's layout is refreshed after any changes. 2. Get formatted text method. This method extracts a substring from this .content between start and end. It retrieves all formatting intervals that overlap with this substring and prepares to merge the text with its associated formatting. It separates the fetch logic from the merge logic. 3. Merge text and formatting method. This method combines the retrieved text with its corresponding formatting intervals. It initializes an empty array result to hold the formatted text segments and sorts the formatting intervals for processing. The snippet sets the stage for iterating over each format to create the final structured output. Now we complete the merge text and formatting method and begins the update layout method. 1. Finalizing merging of text and formatting. It adjusts the start and end indices by accounting for an offset, ensuring they remain within valid bounds. It checks if there is any unformatted text between the current index and the start index, pushing that text with null format into the result. It then pushes the formatted segment from start to end into the result with the corresponding format. If there is any remaining text after the last formatted segment, it adds that unformatted text to the result. 2. Starting update layout method. The update layout method retrieves a substring of the content between start and end. It prepares to fetch the overlapping formatting intervals for that specific range. This code snippet retrieves the formatting information for a specified text range and updates the layout based on the results. 1. Fetching formatting. It uses the search method to obtain formatting intervals within the specified range and casts the result to an array of mapped format. 2. Calculating layout. The method this.calculateLayout is invoked with relevant parameters such as text, formats, and layout details, offset, page number, insert length, insert index. 3. Updating the layout. The layout is updated using this.layoutUpdate by providing it with the starting and ending indices and the calculated layout info. 4. Initiating calculate layout. The calculate layout method initializes variables to prepare for layout calculations, including position tracking, current X, current Y, line height, and page number. This is an exciting and crucial portion of the editor as it handles character positioning and caching. This continues the calculate layout method. 1. State variables. Is new line, is bullet point, and is headline 1. Track whether the current character is at the start of a new line, part of a bullet point, or a headline respectively. Bullet indent is set to 40, which indicates the indentation for bulleted lists. 2. Iterating through text. The code iterates through each character in text. If a new line character N is encountered, it resets the current X position to 0, increments the current Y to move to the next line, and resets the state flags. 3. Bullet point detection. If the character is the start of a new line and matches a bullet point format, a dash followed by a space, the is bullet point flag is set to true. The loop skips the space that follows the dash and sets current X to bullet indent to appropriately indent the bullet point text. Next, we process a section of text to determine if a hash symbol indicates a headline, specifically a headline level 1, and manages the associated layout formatting. 1. Headline detection. If the character is at the start of a new line and is a hash symbol followed by a space, it sets is headline 1 to true, skips over the space, and increments the content index. 2. Index management. The content index is incremented regardless of whether a headline was detected to ensure it represents the correct position in the text. 3. Formatting and layout preparation. The code retrieves the formatting information for the current character using this.getFormatedIndex. It calculates a layout index, which is necessary for fetching any previously stored positioning and layout data, the cache. Style object construction. A style object is created, merging default style with specific format properties, font size, font weight, color, etc., using fallback values when format properties are not available. Now we manage the styling of a headline and check for layout properties regarding characters. 1. Headline font size. If the is headline 1 flag is true, it sets the font size of the style object to 36, indicating a larger font for the headline. 2. Cached dimensions. Two variables, cached width and cached height, are initialized to store the dimensions of the character being processed. 3. Previous layout info check. It checks if prev layout info check exists and if the previous character matches the current one, updating prev layout info accordingly. This allows us to check two possible locations for a cached character. 4. Style comparison. If prev layout info is set and the current character matches, it compares the formatting properties of the current style with those of the previous layout. If any formatting property differs, color, font family, size, weight, line break, italic, underline, it calculates the width and height of the character using the getCharacterBoundingBox function and caches these dimensions. GetCharacterBoundingBox is a relatively expensive operation, which is why we are caching it. Here we continue on with the calculate layout method. 1. Cached dimensions retrieval. If the previous layout information exists, it retrieves the cached width and height from prev layout info. If not, it calculates the current character's dimensions using getCharacterBoundingBox and stores them in cached width and cached height. 2. Cap height calculation. It calculates the character's cap height using getCapHeightPx, which ensures proper text alignment and spacing. 3. Line height adjustment. If the current character is at the start of a new line, it sets line height to the calculated cap height. Otherwise, it updates line height to the maximum value between the current line height and cap height. This assures that the line is as tall as its tallest characters. This portion of calculate layout handles more loop variables and begins layout info insertion. 1. Line overflow handling. If the sum of the current X position and cached width exceeds the container's width, it either resets current X to an indent, if it's a bullet point, or to 0 while incrementing the current Y to move to the next line and resetting line height. This is how we achieve our text wrapping. 2. Page overflow handling. If the current Y position plus the character's cap height exceeds the page's height, it increments current page number, resets current Y to 0, and marks the start of a new line, resetting the bullet point flag. 3. Adding layout information. If the current text is a level 1 headline at the start of a new line, it creates layout entries in the layout info array to represent both the headline marker, hashed, and follows with a space, but both are hidden. To maintain indexing, this code snippet adds layout information for text rendering based on whether the current line is a headline or a bullet point. 1. Headline layout entry. If the current text is a headline, it creates an entry in layout info with properties including the Y position, cache dimensions, cap height, formatting style, and the current page number. 2. Bullet point layout entry. If the current line is a bullet point at the start of a new line, it adds 2 entries. The first entry uses the Unicode bullet character and includes its respective dimensions and formatting. The second entry represents a space for indexing purposes with the same dimensions and position as the bullet point. This part handles the addition of regular text characters to the layout info array. Layout information for text. It creates an entry in layout info for the current character with properties such as its position, X and Y, cache dimensions, and formatting style. The X position is adjusted by adding letter spacing if current X is not 0. 2. X position update. After adding the character, it updates current X. If the character is a level 1 headline at the start of a new line, it keeps current X unchanged. Otherwise, it increments it by the character's width plus the letter spacing. This efficiently manages character placement and spacing in the layout for the text editor. Now we finish calculate layout and move on to get formatted index method. 1. New line reset. It sets the isNewLine flag to false, indicating that the current context is no longer at the beginning of a new line. 2. Return statement. It returns the layout info, which contains accumulated layout data for rendering text. Format retrieval logic. The getFormatedIndex function takes an index and a list of formats, mapped format. It initializes result to null and narrowest range to infinity. It iterates through the provided formats, checking if the given index falls within each format's defined interval between low and high. If the index is within an interval, it calculates the range high-low and updates the result if this interval is narrower than any previously found. This assures that we get the narrowest match for a formatting range. Now I'm going to show the getKerning method. However, we will not need to use it in this video. The getKerning function calculates the kerning spacing between 2 characters based on the provided font data, previous character prevchar, current character char, and font size. If either prevchar or char is absent, it returns 0, indicating no kerning adjustment. It constructs a cache key using the characters and font size to check a kerning cache for previously computed kerning values, enhancing performance by avoiding redundant calculations. This code snippet helps compute spacing adjustments kerning between 2 characters using font metrics. 1. Scale factor calculation. It calculates a scale factor based on the font size and the font's units per em. 2. Glyph run layout. The layout method is called on the font data using the combined previous and current characters, prevchar plus char, producing a glyph run that contains position and glyph data. 3. Validity check. It checks if the glyph run has valid positions for both glyphs. If not, it returns 0. 4. Bounding box retrieval. It retrieves the bounding boxes for both glyphs if they exist to perform further checks. 5. Bounding box validation. It checks if either bounding box 1 or bounding box 2 is undefined or has invalid dimensions, width or height of infinity. If any conditions fail, it returns 0. Overall, the snippet ensures that kerning calculations only proceed with valid glyph dimensions, preventing errors from missing or invalid data. This code snippet calculates the kerning spacing adjustment between 2 glyphs. 1. Space calculation. It calculates space without kerning as the sum of the widths of the bounding boxes of both glyphs, glyph1.bobox.width. It retrieves actual space, the total width covered by the glyph run, glyphrundocs.width. 2. Kerning calculation. The kerning value is computed by finding the difference between actual space and space without kerning, then scaling it by scale factor. Logging information. It logs various spacing metrics for debugging. 4. Caching the result. The calculated kerning is stored in kerning cache using cache key for future reference. 5. Return statement. Finally, it returns the computed kerning value. Now we define a function called getCharacterBoundingBox, which retrieves the bounding box dimensions for a specific character given its font data and style. As I mentioned before, it's an expensive operation, which is why it is cached. Font data retrieval. It searches through an array of font datas to find the appropriate font data that matches the specified font family from the style. Glyph layout. It lays out the specified character using the found font data to obtain the glyph, which contains positioning and bounding information. 3. Bounding box extraction. It retrieves the bounding box from the glyph, which defines the dimensions that enclose the character. 4. Units per em and positioning. It also accesses units per em from font data and the x advance and x offset values from the glyph's positions. 5. Validation check. It checks if the bounding box is valid, not undefined or infinitely small, and ensures units per em is present. If any conditions are not met, it returns a default size of 5 by 5. This code snippet consists of 2 functions. Bounding box return. After validating the bounding box, it calculates and returns the dimensions width and height of the bounding box adjusted for the desired style.font size. The calculations divide the bounding box dimensions by units per em and multiply by font size. If an error occurs during this process, it logs the error. 2. Cap height calculation. The getCapHeightPx function retrieves the font data based on the specified font family and style. It then calculates the cap height in pixels by summing the cap height, ascent, and descent, normalizing them by units per em and scaling by style.font size. These functions enable text layout calculations by returning proper sizes and heights for font rendering. This code snippet defines a multi-page editor class, which manages a text editing interface that can handle multiple pages of content. Key components include properties, pages, an array to store formatted pages. We just built the formatted page class. Visuals, an array for visual elements, not necessarily tied to specific pages. This helps with rendering. Size represents the dimensions of the document. Visible lines, number of lines visible in the editor at once. This is simply all the lines now as we virtualize by page now. Scroll position tracks the current scroll position within the editor. Font data holds font specifications used for rendering the text. Debounce variables rebalance, debounce staggered for controlling layout adjustments. AVG page length, a placeholder for tracking average content length per page. Please note that the code comment in this snippet is outdated. We are in fact detecting overflow dynamically in this video. 2. Constructor initializes the pages with a new formatted page, sets the document properties, size, visible lines, scroll position, font data, and logs the font data for debugging. Next, I provide functionality to retrieve character data and new line counts within a multi-page text editor. 1. getChar@index method. Given a global character index, this method determines the corresponding page and local index of the character. It retrieves a specific character by accessing the page's method getChar@index using the local index. 2. getNewLinesBetween method. This method counts the number of new line characters between 2 global indices. It calculates the starting and ending page indices and local indices for both the starting and ending global indices. A loop is initiated to traverse through pages. Here we perform 2 main functions. Counting new lines. Inside a loop iterating over pages, it retrieves the content of the current page based on a specified range, start index NL to end index NL. It then counts new line characters, n, within that substring by iterating through each character in content and incrementing a count for each new line found. 2. Adding visual elements. The addVisual method allows for adding visual elements to the visuals array. It combines default visual with a new unique identifier generated by UUID-v4 and any additional data provided in the data parameter, ensuring that the visual maintains a consistent structure. This code snippet comprises 3 functions that manage visual elements and content within a multi-page editor. 1. updateVisual method. This method updates a visual element identified by D, merging existing visual properties with new data provided in data. It uses map to create a new array of visuals, updating only the matching visual and returning the others unchanged. 2. getAllContent method. It concatenates the content from all pages in the editor into a single string. The method iterates through each page and appends the entire content to the content variable, which is returned at the end. 3. Delete method. This method is intended to delete a range of text specified by global start and end indices. It begins by determining the corresponding page and local indices for the specified global indices. Now comes the next part of the text deletion process within our multi-page editor. 1. Index calculation. It calculates start page index and end page index based on the global start and end indices, respectively. Local indices, start local index and end local index, are determined for both the start and end positions using the getLocalIndex method. Adjusted local indices are also calculated for new line indices. 2. Callback definition. A callback function is defined to shift all text formatting based on the difference between the local indices of the start and end positions. This allows for adjustments in formatting after the deletion occurs. 3. Deletion process. The delete method on the identified page is called, passing in the calculated local indices, and the callback to handle formatting shifts afterward. Finish delete method. It finishes by calling the render and rebalance method, which handles the both redetermines page overflows dynamically as well as rendering the text to the canvas. Onward. As usual, you can largely ignore the comments. In fact, we no longer use the render visible function. It focuses on rendering visible content in our multi-page editor. 2. Performance marking and calculation. The render visible method uses performance marking to track rendering time. It calculates a start index based on the current scroll position, scaled by a factor of 3. An end index is defined as the start index plus an average page length. 3. Content retrieval. It retrieves formatted text and layout information for the specified index range using helper methods getFormattedText and getLayoutInfo. 4. Combining outputs. The formatted text and layout info are combined using the combined text and layout method to create a unified representation for rendering. This was intended as an optimization, but other routes were taken. This code snippet involves 2 functions related to rendering in our multi-page editor. 1. Performance measurement. The first part measures the time taken to render visible content using performance.measure, marking the start and end of the rendering process and returning the start index along with combined content, formatted text, and layout. 2. Render all method. This method, which we use, initiates rendering for all pages, starting at index 0 and extending to the total length of all pages multiplied by the average page length. It retrieves formatted text and layout information for the entire range, combines them, and logs the results. Finally, it returns the combined output for the full content. Overall, these methods ensure efficient rendering and performance tracking, whether for a specific visible area or for all pages in the editor. Now we define the alter formatting method, which applies style changes to a specified range of text. 1. Parameter definitions. It takes in global start, global end, indices for the text range, format changes, style modifications, and setMaster.json, callback function for updating global state. 2. Index calculations. It calculates the page index, start page index, and end page index, and local indices, start local index, and end local index, based on the provided global indices. 3. Conditional formatting application. If the start and end indices are on the same page, it calls the alter formatting method of that specific page, passing the local indices and the formatting changes to apply them to the text segment. Let's finish the alter formatting function. After a formatting change, render and rebalance is called to refresh the visual representation based on the updated content and the starting page index. Insert method. This method is designed to insert a specified text at a global index, both in regular and new line terms. It starts by marking the performance measurement for insertion with performance.mark insert started. This allows us to use the developer tools to measure execution time. It calculates the relevant page index and the corresponding local indices for both the text and new line using helper methods. A callback function is defined to shift all text formats after inserting the new text, taking into account the index where insertion occurs and the total length of text inserted. This code snippet completes the insert method functionality in a text editor. 1. Text insertion. It calls the insert method on the specified page, this.pages page index, providing the local insertion indices, the text to be added, its formatting, and a callback for adjusting formats post-insertion. 2. Rendering adjustment. After inserting the text, it calls render and rebalance to update the page's visual layout, passing a number of important parameters. 3. Performance tracking. The method marks the end of the insertion process with performance.markInsertEnded and measures the duration of the insertion operation with performance.measure. Overall, this method efficiently handles text insertion while ensuring that the editor's display is updated and performance is monitored. This portion contains 3 method definitions related to inserting JSON data and managing text formatting in our multi-page rich text editor. 1. InsertJSON method accepts a JSON array of type renderItem and a set master JSON parameter. It inserts the JSON data into the first page using this.pages InsertJSON. After insertion, it calls render and rebalance to update the editor's layout and state, indicating that the data has been initialized and specifying the length and starting index of the inserted JSON. This will cause all of the data loaded into the first page to be rebalanced and distributed amongst pages. Shift All Formats method iterates through all pages in the editor, calling shift intervals after index, total inserted length on each page. This method adjusts formatting intervals for each page to account for newly inserted text, ensuring that formatting remains consistent after changes. Render and Rebalance method updates the visual layout of the specified page index, and can initialize layout changes if the initialize parameter is true. Clears any existing debounce timers for delayed processing, although these are no longer needed. Inside the render and rebalance method, we conditionally call the rebalance pages method, depending on whether the initialize flag is true or false. 1. Conditional call. If initialize is true, it calls rebalance pages with default parameters 00 true to reset the page layout. If initialize is false, it passes in the insert length, insert index, and isInsertion parameters to adjust the pages based on new insertions. The commented portions were part of a phased-out optimization technique. 2. Layout update. If initialize is true, it calls update page layouts to ensure the page layout is processed again to reflect any structural changes. This code snippet covers 2 important parts. 1. Final rendering and state update. It generates a renderable representation of the editor's content using this.renderAll, then updates the master JSON state with setMasterJSON renderable all. 2. GetLayoutInfo method. This method collects layout information between 2 indices, start and end. It determines the starting and ending page indices for the given global indices. An optimization is included for scenarios where the specified range falls within a single page, allowing it to directly query the layout for that page by calculating local indices and utilizing page.layout.query. This code snippet performs 2 key tasks. 1. Layout information retrieval. In the for loop, it iterates through all pages from start page to end page. For each page, it determines the local start and end indices based on the page boundaries. It queries the layout for the range specified by page start index and page end index, concatenating the results into an array named result. The method calculates the total length of queried content before returning the complete result. 2. New line counting. The getNewLines helper function counts the number of new line characters in the input string text until a non-new line character is encountered. It increments a new lines counter for each new line character until the first non-new line character appears. This code snippet covers the combined text and layout method. This method takes formatted text, layout information, and indices to create an array of render item objects. It initializes an empty render items array and sets text index to track the position in the formatted text. The method begins by determining the starting page for the provided start index. It then iterates over each layout item in the layout array, extracting relevant properties, start, end, layout info. If layout info is not present, it skips the iteration. This is an important step in merging our data structures for rendering and storage. This handles the processing of layout items. 1. Skipping layout items. It first checks if the layout item's end index is completely before the start index. If so, it increments text index and skips further processing of that layout item. 2. Breaking early. If the layout item's start index exceeds the end index, it breaks out of the processing loop, stopping any further operations. 3. Virtualized indices calculation. It calculates virtualized start based on the start index and the page number, adjusting for a fixed height 3000. It defines virtualized end as the length of the associated layout information. Not all virtualization methods attempted throughout the development of this editor were maintained, just the effective ones. Number 4. Processing characters. Initializes 2 indices. Newline's end index for managing newline positions, and content index for iterating through the content. It enters a loop to iterate through character layout items, checking if the current index is still within the newline limit and potentially skipping further layout handling. Here we process character layouts in the rich text editor by handling formatting and newlines. 1. Next characters calculation. It calculates the subsequent characters in the page's content starting from content index +1 and checks for newlines using getNewlines_char. 2. Updating newline indices. If newlines are found, it updates newline's end index and adjusts content index accordingly, allowing further processing to account for these newlines. This will help us maintain where we insert newlines and where we don't. 3. Formatting retrieval. It retrieves formatting information for the current character based on I, searching through formatting for the relevant text and format pairs, and extracts the last text item's format if available. Here we continue processing layout information in our multi-page rich text editor. 1. Rendering characters. It constructs an object for each character. This object is then pushed into the render items array. 2. Content index increment. The content index variable is incremented after processing each character. Newline handling. If newlines were identified previously, it enters a loop where it adds newline character objects to the render items for each newline detected. Here we simply finish up the previous method. Additionally, the getTextLength method calculates the total length of text across all pages. It can consider either the total character count or exclude newlines based on the withNewlines parameter. If before page is defined, it sums the lengths of all pages up to, but not including, the specified page, handling the newline considerations accordingly. In this snippet, the getTextLength method continues to calculate the total length of text across pages. If before page is undefined, it checks whether to include newlines in the count. If withNewlines is true, it simply adds the full length of the page content. If not, it removes newlines and adds the length of the remaining content to total. Following this, the rebalance pages method begins with a performance marker and determines the total number of pages. If initialize is true, it calculates the total number of pages based on the content length of the first page divided by the average page length, ensuring that we initialize with a reasonable starting page count. This portion iterates through pages starting from start page index up to total pages. 1. Page access. For each page, it retrieves the current page using this.pagesI. If the current page is undefined, it breaks the loop. 2. Next page handling. It checks for the next page, creating a new formatted page if it doesn't exist. 3. Page number assignment. It assigns the current page's number and the next page's number based on the loop index. 4. Layout calculation. It calls the calculateLayout method on the current page, passing its content, formatting information, and other parameters like change length and change index for layout adjustments. This code snippet handles the layout of text across pages in our rich text editor. 1. Next page start index. It determines the index in layout info where the next page begins by looking for the first entry where the page property is greater than the current page index. 2. Overflow handling. If a next page start index is found, i.e. not made a 1, it identifies the overflow text, content that exceeds the current page's layout, and its associated formatting. It deletes the overflow content from the current page and inserts it into the next page, applying the relevant formatting or a default style if none exists. Notice how the next page is determined by the layout function, rather than using a hard-coded character count. This is critical for a multi-page editor. 3. Underflow handling. If the next page start index is not found and the current operation isn't an insertion while the next page has content, it prepares to calculate the layout for the next page. Overall, the snippet manages both overflow, excess content moving to the next page, and potential underflow, adjusting the next page's layout when necessary. Here we do a couple things. 1. Content movement check. It searches for the index of content that needs to move from the next page to the current page, looking for any entries indicating content that belongs to pages beyond I+1. 2. Content movement handling. If content that needs to be moved is found, content to move index -1, it extracts that content and its formatting. It then inserts the extracted content into the end of the current page while maintaining its formatting and deletes it from next page. Overall, this snippet addresses transferring excess content from the next page back to the current page, thus handling underflow. This code snippet handles the movement of content between pages in our rich text editor. 1. Full content transfer. If all the content from the next page fits into the current page, it moves the entire content and its associated formatting into the current page, deleting the content from next page. 2. Page management. If the next page still contains content and there isn't already a subsequent page, I+1, it pushes the next page onto the this.pages array. Conversely, if the next page is empty, but there is a subsequent page, it removes the empty next page from the array, decrements the total pages, and adjusts the loop index, I, to ensure proper reevaluation in the next iteration. This succinctly manages the pagination and content flow, ensuring that pages are appropriately populated and cleaned up based on their content. This code snippet performs several tasks related to managing page layouts in our rich text editor. 1. Layout update. It starts by updating the layout of the page at start page index, passing parameters that define the range of content to be considered, along with change length and change index, which pertain to modifications made. 2. Performance measurement. It records performance metrics by marking the beginning and end of the rebalance operation, measuring the time taken for this process. 3. Layout updating. The update page layouts method iterates over subsequent pages starting from start page index +1 and updates their layouts based on their full content lengths. Thanks to our caching method, this is fast. 4. Page index lookup. The getPageIndex for global index method initializes an accumulator index and iterates through the pages to determine the respective page for a given global index. It also handles newline inclusion based on the with newlines flag, preparing to find lengths accordingly. Next, we have 2 functions related to indexing in our multi-page rich text editor. 1. Global to page index mapping. The first part determines the page index for a given global index. It loops through the pages, accumulating the total content length until the accum index exceeds global index, at which point it returns the current page index. If no suitable page is found, it defaults to returning the last page index. 2. Local index calculation. The getLocalIndex function initializes an accum index to track content length, and if on the first page and including new lines, extracts content up to global index. It counts characters, tracking total new lines and non-new line characters. This code snippet continues the getLocalIndex function, handling the calculation of a local index within a specified page. 1. Counting characters. It checks if the character count -1 exceeds the global index. If so, it breaks out of the loop, indicating that the desired location has been reached. 2. Returning adjusted index. Once the loop concludes, it returns global index adjusted by the total number of new lines encountered, effectively mapping the global index to its corresponding local index, factoring in line breaks. 3. Accumulating lengths for given pages. For pages preceding page index, it updates accum index by summing the lengths of their content. If with new lines is false, it computes the length without counting new line characters by removing them from the content before summing. For our final piece of code, formatted text retrieval. The getFormatedText function is designed to fetch formatted text between a specified start index and end index. It initializes an array to hold results and determines the start and end pages based on the global indices. For each page from start page to end page, it calculates local indices for the start and end of formatted text retrieval. If on the starting or ending page, it uses local indices based on the global indices. Otherwise, it uses the entire page content. It aggregates formatted text from each page by calling getFormatedText on each page and concatenates these results into the result array. And that's about it. You should now be able to integrate this editor into any web-based rendering system, such as Canvas with a library like Canva. Integration would involve hooking up event handlers, setting indexes on the window object correctly, and rendering correctly. You can see an example of this on my GitHub where this project lives. I will add the link to the description. Thank you so much for watching. I sure hope you find my videos informative and unique. Please like or subscribe. Thank you.